Hey, algebra students, in this lesson, we are going to be learning how to multiply radical expressions. Now, remember, an expression in mathematics is a statement that has numbers, variables, and arithmetic operators. You can also include things like radicals, like we're going to do dealing with here, or squares or cubes, all of those sorts of things. You'll see that all of the things in our lesson practice involve expressions. We have mathematical expressions, okay? And what makes these expressions unique is that they all involve radicals in some way. So all of these are square root radicals. We're going to have to deal with these square root radicals as we solve this problem. So that's one of the things we're going to be doing. And then additionally, um, we're going to be revisiting the product property of radicals, which says that if we have a number under a radical that can be factored, we can rewrite it as the product of the factors. For example, the square root of 6 could be rewritten as the square root of 2 times the square root of 3. There's not much use in doing that for the square root of 6. The square root of 18, on the other hand, could be written out the square root of 2 times the square root of 9, and then the square root of 9 can be evaluated. So those are the sorts of things that we're going to be doing as we practice simplifying radicals, multiplying radical expressions together, and we are going to simplify them to the simplest form after we're done. Okay, let's begin with letter A. This one is easy. It's going to be the square root of 5 times the square root of 3. I'm just going to go ahead and grab my square root symbol here. We're going to be using that regularly throughout this lesson. So there we go. Let's see if we could search for it. Oh, there it is. Okay, excellent. The square root of 5 times the square root of 3 is the square root of 15, and I'm done with the problem. Square root of 15 can't be simplified any further. It doesn't have any perfect square factors. On to letter B. Now, when I have one like this, where I have a number out in front and then a number under the radical, here's how we work these. And I'm multiplying these together. Multiply the numbers in front. 3 times 2 is 6. Multiply the numbers under the radical and keep it under the radical. Okay, so that's going to be 7 times 3 is 21. Now we ask ourselves, does 21 have any perfect square factors? I can't multiply 9 to get 21. Can't do 4, obviously. So, nope, no perfect square factors. This is the simplified form of letter B. Letter C. I'm going to encourage you to look at these as 3 times the square root of 6 times 3 times the square root of 6. Now, if you want to, you could square the 3 and square the square root of 6. And that's a little more straightforward. But this shows exactly what we're doing. 3 times the square root of 6 times 3 times the square root of 6 is 9 times the square root of 6 times the square root of 6 is just 6. 9 times 6 is 54. And that's our answer for letter C. On to letter D. Oh, this one's going to get a little tricky. First, I'm going to multiply what's in front. 3 times 1 is just 3 out front, times the square root of, then I'm going to multiply what's under the radicals. What's 3x times 2x? 6x squared. Okay? Now, this is all under the radical, and just to emphasize that, I'm going to put this in parentheses after the radical. So let's see if we can make that look right here. There we go. Okay, now what's the square root of 6x squared? Well, I need to simplify this a little bit. I can take the square root of x squared. The square root of x squared is just x. So this is going to be 3x, but the square root of 6, so I break this down to the square root of 6 times the square root of x squared. I evaluated the square root of x squared to just be x. What about the square root of 6? Does that evaluate to anything simpler? There's no perfect square factors in 6. I can't multiply 4 by something to get 6. So that's going to be it. 3 times x times the square root of 6. Hey, let's just go back and check and make sure all of our answers are correct so far. Just make sure I'm not making any mistakes. Okay, there we go. Let's move on to letter E. We're about halfway done. Square root of 7 times 2 plus, square root of 7 times 2 plus the square root of 4. This square root of 7 on the outside is going to distribute. This is going to become 2 times the square root of 7 plus, because there's a plus sign in the middle, the square root of 4 times the square root of 7. Well, the square root of 4 times the square root of 7 can be simplified to the square root of 28. So this is 2 square root of 7 plus the square root of 28. And then the square root of 28 does have a perfect square factor. The square root of 28 is 4. So I'm going to write 2 square root of 7 plus the square root of 4 times the square root of 7, right? Square root of 4 becomes 2 because the square root of 4 can be evaluated. So I have 2 times the square root of 7 plus 2 times the square root of 7. That gives me an answer of 4 times the square root of 7. I can add the coefficients. Now, let's just go back and ask ourselves, was there an easier way to do this one? Well, square root of 4 could have been evaluated right away to be 2. 2 plus 2 is 4. This is 4 times the square root of 7. So I didn't actually have to distribute in this one. If I was perceptive, I could have evaluated the square root first and then solved it. Let's do that for letter F and see if that works out for us. In letter F, I notice I also have a square root of 4. So what happens if I just simplify the square root to start? So this becomes the square root of 5 times 2 minus the square root of 3. Is that going to help me out at all? Well, in this one, not as much as it would have in the last one, because I'm still going to have to distribute the square root of 5 into here, okay? Square root of 5 times 2 is 2 times the square root of 5, minus the square root of 5 times 3, by the way, minus, I'm keeping the minus sign here, is going to be the square root of 15. Square root of 15 can't be simplified any further. 2 times the square root of 5 can't be simplified any further. I can't combine them because they don't have the same radical at the end. So this should just be 2 times the square root of 5 minus the square root of 15. Bam, got the right answer. Let's go to letter G. Letter G, I've got, this is a this is gonna multiply out to be a trinomial, right? Because this is like a factored trinomial. Well, let's just see what this becomes. I'm gonna do first, outer, inner, last. We're gonna FOIL it. 5 times 4 is 20. There's going to be minus 5 times the square root of 6. Those are the outers. Plus 4 times the square root of 9. Those are the inners. And then the last are going to be minus the square root of 9 times the square root of 6. Okay, let's go ahead and solve and simplify these. So it's going to be 20 minus 5 square root of 6. There's nothing I can do with that one. 6 can't be simplified any further. There's no perfect squares in 6. But 4 times the square root of 9, well, the square root of 9 is 3. So I just multiply 4 times 3 and get 12. 4 times 3 is 12. Minus, and then the square root of 9 is 3. So this is going to be minus 3 times the square root of 6. All right, I've got some things that I can combine here now. 20 plus 12 is 32. And then negative 5 square roots of 6 minus 3 square roots of 6 is minus 8 square roots of 6. And that should be the right answer for letter G. Let's just check and see if I got it right. 32 minus 8 square roots of 6. There we go. Letter H. For this one, 4 minus the square root of 7 squared. Why, if I wanted to, I could use one of those special products on this one. Remember, if you have a number squared, the result always is the same thing. It's the first number squared, 16, plus 2 times the first number times the last number. So it's going to be 2 times 4 is 8 times square root of 7. And this is technically it's negative square root of 7. So I'm going to have to multiply that. So 2 times 4 is 8 times the negative square root of 7 is minus 8 square root of 7. And then the last number squared, square root of 7 squared is just 7. And it's negative square root of 7 times the negative square root of 7. So it's positive 7. Okay? So I just used a special product to evaluate this. Now, if I wanted to, I could write this out as 4 minus the square root of 7 times 4 minus the square root of 7 and FOIL it out. But if you remember your special products, it's going to make things a little easier for you. So this one, when I simplify it further, it's going to be 23 minus 8 square roots of 7. And then I think that's all I can do. Let's just see if we got the right answer here. 23 minus 8 square roots of 7. All right. Finally, letter I. The square dance floor at the local community building is being replaced. The floor's side length is 32 plus the square root of 13 feet. What is the area? Well, the area is just the side length squared. So this is going to be another special product problem. 32 plus the square root of 13 squared. Okay? And if you know your special products, which you should at this point, you know that it's going to be the first number squared. Let's see, 32 times 32. I am going to use a calculator for that one. That's going to give me 1,024. Okay. Plus 2 times the first number, 64, times the second number, square root of 13. So 2 times 32 times the square root of 13. I'm just following the pattern here, folks. It's all you can do. And then the last number squared. So it's going to be plus 13. Square root of 13 squared is just plus 13. So this is going to end up being 1,037. 1024 plus 13 is 1,037 plus 64 square roots of 13. And let's just make sure we did this one right. There it is. The only thing I forgot to put, it's really important to put, so I should have wrote it, is square feet. All right, now you know how to do these problems involving multiplying radicals. You should be able to do numbers 1 through 30 for next time.